Hi everyone. So in this video, I'm going to be going over the fourth question of the exam because a lot of people, I think, didn't do super well because they probably just freaked out because it looked a little because of the high numbers or because of something. And I think the stress made everyone do significantly worse than they should have because the problem itself is not too difficult. But I kind of want to go over it because roughly 2/3 of the class got the answer wrong. Um, and so I want to, well, actually, technically more than that. But I want to kind of go over it to see so that people kind of understand how to do this and how to kind of go over something like this. First off, if you're ever doing an exam, don't stress. Like adding stress into it, like freaking out, generally makes the problems harder. I know it's hard to control, so like it's easy to say, "Oh yeah, just don't stress," and then like you're there and you're stressing and you just can't stop. But try your hardest not to, because generally, if you're stressing, your brain can't actually focus on the problem. If you do stress, just stop, breathe, and take the problem one step at a time. That generally will help. Um, so let's kind of see how this problem works. I'm going to go over first how to do it, and then I'm going to go over some of the common mistakes that I saw, and so that people don't make those mistakes again. So first, or actually, I might do it. Yeah, I might do this throughout the entire thing, but you need to so make sure to kind of go through this and see how I'm doing it, so that you don't make these mistakes again, because in future exams or homeworks, we'll be watching out for something. Some things I kind of just didn't remove points because already most people got a lot of points deducted. But so I didn't want to remove more points and make it even worse. But so just note that I was super lenient on a lot of things, even if the point numbers do seem really low. So let me kind of go through this. And the main easy thing, so the main thing with this problem is, as always, kind of go over and see what the pieces of information you want. So I know right off the bat, I'm told that I roll so in this place, I've already replaced my numbers. But so I'm supposing that I roll a 415-sided dice until you roll a number that's already been rolled. And then it's asking, what is the exact probability? So here is the question. What is the exact probability that it takes 5 or more rolls until you roll a number that's already been rolled before? And here is the key part that most people kind of screwed up on. This, 5 or more rolls. And I'll get to that in a minute. So if you think about this for a few seconds, first let's set up a variable, right? Let x be the number of rolls until you roll a number that's already been rolled. So a lot of people, which correctly did, is what you really want to calculate is this, right? This is what we want to calculate. This makes me happy. So I guess I should do a little green happy face here on the side. This is correct. This is good. This is what you should be doing, right? I lay down what my event is. I say, let x be the number of rolls until you roll a number that's already been rolled. And then I'm saying I want x to be greater than or equal to 5, right? Because I want 5 or more, right? So I want numbers greater than 5. First common mistake people do. Oh, wait. First, I'm just going to go through this, and then I'll go through this slower. Sorry. I forgot that I'm doing this quick first, and then we'll go slower. So what is this? This is basically the same thing as saying the probability that the first four rolls are all different. First 4 rows are all different, right? In other words, we don't have the same role in the first 4. From 5 on, I don't really care. I just care about those first 4. They all have to be different, because if I have 2 of them that are the same, then I fail this condition that it takes 5 or more to get this to happen, right? So what are the chances that the first 4 rows are all different? Well, for the first row, it's always different. So I'll have 415 out of 415. For the second row, I have 414 out of 415. Then the third rule, and then the fourth rule. And this, if you plug into your calculator, you end up getting 0.9856, which is roughly 98.56%. So you'll notice this problem takes almost no time. That's it. It's 2 lines, right? 1, 2. It's not a difficult problem. The thing is, most people kind of took this as a birthday problem, which is correct. There's a birthday problem hidden in here. And I'm going to go through that part, which is kind of how I had imagined doing this. We're going to go through that part, and at the same time, I'm going to go through common student mistakes. So we'll cross this part out. And we'll first start off with this part here. So we'll call this the birthday version. If I have px greater than or equal to 5, the first big mistake is I saw people write x equal 5 and then p of x greater than or equal to 5. That is bad. This is, I shouldn't put a line through it. This is bad. Don't ever do this. Because what this is saying is x is equal to 5. So what you're saying is, what's the probability that 5 is greater than or equal to 5? Well, this is always equal to 1. 5 is always greater than or equal to 1. That is not what we're trying to calculate, right? X here really needs to be this event. You have to state what your event is in this way. And this is going to be easier when we look at random variables, because you're going to have to be able to state these things much more clearly. But you cannot state that x is equal to 5, and then what's the probability that x is greater than or equal to 5? Mathematically, this doesn't work. In the exam, I didn't take points off for this because we're still learning random variables. But note, in the future, if you do this, you're losing points, because this is mathematically just incorrect. It's very bad, because it's not what you're trying to calculate. You're saying x is equal to 5, and this is just not what you want. So this is one big mistake that I saw a lot of people do. So just note, do not make this mistake when we start doing random variables from here on out. Okay, so from here, what most people did, which is good, is they said that this is equal to 1 minus, and then here's where the problem started. What a lot of people did is they kind of went in a couple different directions. But notice when we talk about complements, you have to think of complement. So what I have to think is, if I have x greater than or equal to 5, I want to know what is the opposite of x greater than or equal to 5. Right? And a lot of people kind of screwed up in a couple different ways. What some people did, and I'll do these in red, mistakes. Some said that you don't, actually, yeah. So basically what a lot of people did in this case is they looked at the probability from 1 to 5. Right? So a lot of people did this thing. They looked at probability of 1 times probability of 2 times probability of 3 times probability of 4 times probability of 5. But notice what you're doing here. First off, you're looking at 5 here. And that's not the opposite here, right? So here, if I want opposite of x greater than or equal to 5, the opposite here is x is less than or equal to 4. Or another way, a better way actually to say this is x is less than 5. X has to be strictly less than 5. That's the opposite, right? If I have a real number line, right, if I have r, here's my 5. If I'm saying, oops, I should make my 5 a little cleaner. If I'm saying I want to look at all these things, the opposite of that is, well, all of these things. Everything up until 5. I can't include 5 because 5's on the right-hand side set. So it has to be x less than 5. So a lot of times, if you did this, P.S. I should actually mark where points are so people know where the points are. I'll do this in pink. Writing events, and saying what variables are, is 2 points. So if you didn't give me your variable names or you didn't tell me what the events are, it's 2 points off. That's it. Now, I'm going to mention this now before people kind of complain. It might seem like I'm taking a lot of points off, but this problem is, if you notice, just 2 steps. And if I have 10 points to give, that means each of these steps are going to be a lot of points. And so it might seem really harsh that I'm taking off a lot of points, but in reality, I just don't have a good way to distribute these points anyway. So I'm sorry in that regards, but I don't really have too much choice in this manner. So I tried to distribute it as well as I could, but it's still a lot of points for each thing. It is what it is. So this part is 2 points. This less than or equal to 5. So if you added this p of 5, this was minus 2 points. So the right number of terms, had to be correct. And so this was worth about 2 points. And I think about 43% of students got this wrong. So 43% of people did not notice that the opposite of x greater than or equal to 5 is strictly less than 5. And another way of writing this is just to say x is less than or equal to 4. So you didn't lose these 2 points if you basically had these 4. Now this is still technically wrong, and I'll get to that in a minute. But if you didn't have this term, you would have gained those 2 points. Now, why is this multiplication wrong? Because if you think about this, what does this mean, right? If I look at p is 5 or more, right? So remember, this is 5 or more, or I should be adding these things, right? So I should have p of 5 plus p of 6, because 6 is more, plus p of 7, etc. I want all the numbers that are greater than. And this is another massive mistake that people made. A lot of people said that this is equal to p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5, right? But look at this. I'm saying x has to be greater than or equal to 5. 1 is not greater than or equal to 5. It should automatically not show up. I'm saying 5 or more. So 1 should not even be in the picture. 2, same thing. 3, same thing. 4, same thing. Like, those numbers should not even be there. So it's like it's automatically wrong in this perspective. So this is kind of one thing to kind of note, that if you had stopped and written down this x greater than or equal to 5 and tried to do the next step, you should automatically have noticed that, wait, something is weird, because I shouldn't have numbers less than 5 when I'm calculating a probability of things more than 5. So this is why I keep saying you need to be clear about what you're writing and what your steps are. Because a lot of people screwed this up because they just didn't notice that they were looking at numbers less than 5, but they're trying to calculate something more than 5. If you did this, this was minus 3 points. So these two things, this and this multiplication is minus 3. Is minus 3 points. Why? Because both of these are actually representing the same thing, right? This P1 plus P2 plus P3 plus P4 plus P5 is equal to 1 minus P1 times P2 times P3 times P4 times P5, depending on how your variables are working. Where does this fit in? This is coming from the tree. So if I have my tree, we have something like this, right? So obviously, if I do my first step, so here's 0, I'm either going to have P1 or, as most people did, N1. And that's okay. But here, a lot of people kind of screwed this up and moved the N1 here. This is bad. Remember that in a tree diagram, you should always have things on top of one another. This is the first roll. If I did one roll, P1 and N1 should be on top of each other because it's the first roll. Notice how I'm always putting everything on top of one another. And that's how you know which roll is which roll. So here I have P2, P3, P4, N2, N3, N4, P5, and 5. Here, Pi is, in other words, is Pi, which is, now here I've already written this down. The number of rolls until you roll a number that has already been rolled is probability that the ith roll is when the first time we see a duplicate. And I think in this case, most people did this tree diagram correctly. They labeled everything correctly, and that was okay. So here I will write the numbers down again, just so people can see. So this one was 0 out of 415, 1 out of 415, 2 out of 415, 3 out of 415, 4 out of 415. And then on the bottoms, I'll do these in red because these are the wrong ones. These are the when they're different. 413 over 415, 414 over 415, 412, and 411 over 415. Okay, so the reason why I'm saying these two here are the same, this top one up here and this bottom one down here, is because what people did is they took this summation up top, P1 plus P2, I'll do this in red. They did P1 plus P2 plus P3 plus P4. Well, they added a plus P5, but again, we just saw earlier that's wrong because we want everything less than 5. And we said this is equal to 1 minus N4 in this case, right? Because we want whatever's on top of each other. So minus N4. I'll do this because this is technically wrong, but just in case people did it this way, add a plus P5. So this is equal to 1 minus N4, or if you're doing this, this is N5. And so this is where this kind of thing is coming from, right? This is the N4 is where people had this multiplication, right? 1, 2, 3, 4, right? 1, 2, yeah, right? So N4 in this case was just a multiplication from these kind of thing. And this is where the birthday problem is kind of coming in and where things are kind of wrong. Because what you would notice is if we did this using the actual thing, if I had P of x greater than or equal to 5, so if I did this properly, P of x greater than or equal to 5, this I would know it's the opposite, right? I have 1 minus P x less than or equal to 4, which is what most people calculated. This part here is what most people did. This is equal to P of 1. I guess I'll do this thing, P1 plus P2 plus P3 plus P4. So in other words, I can translate this into my 1 minus N4. 1 minus N4. And N4 here is, look at what I have here. I have this kind of thing. So I have 1 minus, well actually, I can just pull out the minus, and I get N4. And if I look at my tree diagram, my N4 is 415 over 415 times 414 over 415 times 413 over 415 times 412 over 415, which this is identical to our first way of doing it. So this is one way to kind of do this. And that's a perfectly okay way to do this. This is also fast as well. It took me a little while because I'm also showing you all the ways people make mistakes and what's kind of wrong with them. But there's also that. So notice how so far I've just talked about 2, 4, 5, 5, 6, 7 points. So I've only talked about 7 points. Note that, I guess I should talk about this, about 34, I'll write these in purple. So 34% of the class got this wrong. The number of terms, we said about 43% of the class got this wrong. This minus 3 points where people were looking at the wrong thing to calculate, this was about 47% of the class did this wrong. So this is a major amount of people who didn't just read the question, didn't slow down and take the time to actually look at the question. Whether that was because they ran out of time from the third question or they were just stressed. But like a good chunk of people just didn't kind of keep going from there. And the last 2%, so I also did, so a lot of people were calculating the tree diagram wrong. And this, I mean, I can't really say too much, but note that, well, no, I can. So a lot of things, so this is about 2 points as well, basically knowing what these percentages are, and about 11% of people did this part wrong. And the thing is, what they did wrong is, I'll mention this, is they basically said something like P3 is equal to 2 out of 40 to 415. And this is not true. What they're basically doing, or what basically happened here, is they looked at P3 and they said, oh, what's the number in front of it? 2 out of 415, which is where they got this number from. But remember, when we're looking at a tree diagram, we have to multiply all the things before, all the cases that come before it. So you're forgetting this 415 and this 414. And this is where problems kind of arose. So if you did calculation errors or stuff like this, about 11% kind of did this part wrong as well. And then if you got the wrong answer, then that was 1 point off as well. So that was where the 10 points were. So minus 1 point for wrong answer. And this, about 67% of people got this one wrong. So 67% of people got minus 1 point for the wrong answer. I don't know what more to say, except like, when you look at these problems, I know it's very easy to stress. I know it's very easy to like be like, oh my God, what's happening? There's big numbers. This thing is happening. Like I'm in the middle of an exam. Like take a minute, breathe, and just go slow. When you're double checking your work, these are the things you should be double checking of, okay, I have x greater than or equal to 5. Am I actually doing x greater than or equal to 5 or not? I think some people had a probability that was greater than 1. If you see a probability greater than 1, you should be like, I did something wrong. What am I doing wrong? So yeah, like this is kind of the things you need to double check. This is why you have that extra hour. That first hour is really just to do the exam. If you run out of time, it's like this, that time is really when the time is made for the exam. Everything after is just to double check your work. You shouldn't be working on the exam in that second hour. And the questions themselves are designed to be relatively quick. Like you saw, this took less than 5, it took like 2 minutes to do. Like it's really, really not that long of a problem. Even if you had done it this way, where you, so the way to do this part properly was basically this, with all the kind of text above, like writing what my variables, etc. are. This part itself was roughly 10, 15, like, no, sorry. It's like 4 minutes, 4 or 5 minutes. Like, it's really not that long. But I think people just freaked out. And this is me kind of saying it's the freaking out that is making these things harder for you than if you just try to calm. And like I said, it's easy to say it. It's a whole nother thing when you're in the situation and you're stressed and you got a million things on your mind. And like, I totally get it. I've done exams before. And I think it's one of those life lessons of you have to try to learn how to cope with stuff like this because these things happen. Like they happen less often. There's less tests in the real world. But in a university, these things happen. So you need to learn how to control that stress and how to think. So how not to panic, in essence. And it's a hard thing, but I believe in you. Some people, so another way to kind of do this, it's a lot longer, but it's basically the same idea, is some people actually just calculated it at this point. So some people sat and calculated this minus P1 plus P2 plus P3 plus P4. This made it kind of intense for some people because for some X was equal, or not X, I guess it was S or T, I forget. T was equal to 10, so that made this really long. But you could have done it this way, and your P's are just going to be whatever your P from the diagram is. So P1 is 0. P2 is going to be 4, 15, and 1. So I have, I guess I'll just keep the 1. And then the other one I have is 2 over 415 times 414 over 415. And then so this was your other kind of way to kind of do this. And this one was just a lot of calculator work, but this was technically correct. This was just, if you notice the birthday problem, it made it easier, basically. Oh, another thing I noticed, and a massive problem as well, a lot of people, and I don't know why, they basically went from, they changed addition to multiplication. So let me increase the thing. Another common problem, I need to do it here. Yes. Another common problem was a lot of people did P1 plus P2 plus P3. I'll just do this. And they said this is equal to 1 minus N3, which is equal to 1 minus P1 times P2 times P3. Like, no. Like, the pluses, like in this case, this doesn't work. You can't just make the pluses magically turn into multiplication. Like, and then in this case, most of the time what they did is they did something like this. Right? And this is wrong because you're basically saying like adding these should be the same as multiplying them or stuff like that. And sometimes it was even done more like, some people even did this, 1 plus or 1 minus P1 plus P2 plus P3. And then they said this is equal to 1 times this, which for me is even worse. Because what you're basically saying is your pluses somehow became multiplication. You can't just change your order of operations because that's what has to fit into the formula. If you're saying, oh, I need multiplication here, but I have plus here, you shouldn't just be like, oh, I'm just going to change it from a plus to a multiplication. Math doesn't work that way. If you're writing a plus here and you want to change it to multiplication, that means you're either doing something wrong or you're thinking something wrong. If you notice above, if you had written this was good. That was correct. This is good. But when you switched it to this, now it suddenly became wrong. Because you really wanted to force, like you basically wanted to force the birthday problem in that multiplication setting when you have addition. And this is one of those things, don't try to force math. Math should flow nicely in the sense that one thing should always equal the other in a nice way. If you're just changing symbols and you're like, oh, I just need a minus here instead to make it work, no, it doesn't work that way. Like, you have to kind of go slowly in these ways. Anyway, this video is super long. I really wanted to go through all the errors people had made, like the major errors, because I really want people to get better. Like I said, I want you all to get better. I want you to learn how to do these things. And so I wanted to kind of go over this. If there's any questions, feel free to ask. I'll give more. I'm going to email everyone in a few minutes while I'm posting this online. If there's any questions, feel free to ask. And yeah, hopefully next time it'll be a little better. I believe in you all. You all got this. And yeah, have a good rest of your reading week. And I will see you, I guess, soonish. So, bye.